Calibration of instrumentation equipment is the process of determining the relationship between the measurement values produced by the equipment and the true values of the quantity being measured. This process is typically performed using a set of known standards that are traceable to a higher level of measurement. Traceability refers to the ability to trace the measurement values produced by an instrument or system back to a higher level of measurement through an unbroken chain of calibrations. This chain of calibrations is typically established through the use of a series of standards, each of which is traceable to a higher level of measurement. Standards are used in the calibration process to establish the relationship between the measurement values produced by the equipment and the true values of the quantity being measured. These standards can include physical artifacts, such as weights and length standards, as well as primary and secondary measurement standards. Examples of physical artifacts that can be used as standards include weight standards, such as a set of precision weights, and length standards, such as a set of precision gauge blocks. Examples of primary measurement standards include a primary standard for temperature measurement, such as a triple-point cell, and a primary standard for electrical measurements, such as a Josephson array. Secondary measurement standards are a type of standard that is not as accurate as primary measurement standards but can still be used to calibrate equipment. These standards are typically calibrated using primary measurement standards. An example of a secondary measurement standard is a thermocouple. It is important to note that calibration should be done by a professional, and should follow the guidelines of the ISO 17025 standard, which provides the general requirements for the competence of testing and calibration laboratories. For example, if I'm to define calibration concerning temperature and pH, I would say, calibration of temperature instrumentation equipment involves determining the relationship between the measurement values produced by the equipment and the true temperature of the environment or sample being measured. This process is typically performed using a set of known temperature standards, such as thermocouples or resistance temperature detectors, RTDs, that are traceable to a higher level of measurement, such as a primary standard. The process of calibrating temperature instrumentation typically involves exposing the instrument to a series of known temperatures, either by immersing it in a bath of liquid or by exposing it to a series of temperature steps and comparing the measurement values produced by the instrument to the known temperatures. The difference between the measurement values and the known temperatures is used to adjust the instrument so that it produces accurate temperature measurements. Calibration of pH instrumentation equipment involves determining the relationship between the measurement values produced by the equipment and the true pH of the sample being measured. This process is typically performed using a set of known pH standards, such as buffer solutions with known pH values, that are traceable to a higher level of measurement. The process of calibrating pH instrumentation typically involves immersing the instrument in a series of buffer solutions with known pH values and comparing the measurement values produced by the instrument to the known pH values. The difference between the measurement values and the known pH values is used to adjust the instrument so that it produces accurate pH measurements. It is important to note that temperature and pH calibration should be done periodically, as the instrument drifts over time, and the accuracy may be affected by environmental conditions, such as temperature and humidity. And also, the equipment should be cleaned and maintained before and after calibration, to ensure the accuracy of the measurements.